Welcome to the lesson Matrices and Transformation. The question reads, the vertices of a rectangle ABCD are A, negative 1, 1, B, 1, 1, C, 1, 4, and D, negative 1, 4. Now the vertices of its image under transformation T are A prime 1, 1, B prime 3, 1, C prime 9, 4, and D prime are these 7, 4. A, part 1, draw on the grid provided the rectangle ABCD and its image A prime, B prime, C prime, D prime under transformation T. Part 2 of the question, describe fully the transformation T. Then the third part of the question, determine the matrix of transformation T. B, on the same grid as in A, draw rectangle A double prime, B double prime, C double prime, D double prime, the image of rectangle ABCD under the stretch with y, line y is equals to 1 as the invariant line, and a stretch factor of 2. State the coordinates of A double prime, B double prime, C double prime, and D double prime. So those are the questions. Let's begin with the first part of the question, which we are required to draw on the grid provided rectangle ABCD and its image. That is quite simple since we have the coordinates of the object and the image. It's just a matter of plotting them, the x and the y coordinates. That is 2 marks. So to save time, most of the students do not have a problem with plotting the object or points. That one is done in Form 1. So let's go to the plotting. I've already done the plotting. So when you plot, this is what you get when you plot ABCD and its image. So the image is in red. So that is what you get, and that is 2 marks for each of the object and the image, 1 mark each. So let's go to the second question. And the second question, you're supposed to describe the transformation T fully. Now this is a transformation that maps a triangle ABCD to A prime, B prime, C prime, and D prime. So looking at the kind of transformation that you can see, we need to think of all the transformations that we know. This one, there is a rotation, there is a reflection, there is a translation, which one have I not said? There is enlargement, then there is shear, there is stretch. So among all those, we need to identify, the student need to look at all the transformation and identify the type of transformation. That is the first way. The second way, if you know how to identify the type of transformation using the matrix, you can obtain the matrix of this transformation. Since you are given the object points and the image points, it is possible to obtain the matrix of transformation. But in this case, you don't need to go to that since it is in the second part of the question. You need to understand the 2 types of transformation. There is isometric transformation and non-isometric transformation. Isometric transformation is the one that does not change both the object and the image. So after transformation, the shape and the size of the object and the image remain the same. In this case, you can see the object and the image. This is non-isometric. The object and the image are not of the same size and shape. So rotation cannot be for this case, since that one is isometric. Reflection cannot be in this case. Translation cannot be. So we remain with 2 transformation. Enlargement cannot be because that one again doesn't change. Enlargement, the shape remains the same, only the size that changes. So with all those, you remain with 2 to decide on shear and stretch. But when you can look at this diagram, shear is possible. So stretch, let's think of stretch. A stretch is a transformation where the points move perpendicularly from the invariant line. When I look at these, like I look at the invariant line, which is the x-axis point are not moving perpendicularly, and so this one is not stretched. So automatically, this is a shear. There are two types of shear: a shear that is parallel to the x-axis with the x-axis invariant, then a shear parallel to the y-axis with the y-axis invariant. So when you look at these, you notice that this one is a shear that is parallel to the x-axis. You can see the points are moving. When you look at the point, the y coordinate of these points are not changing. The y coordinates are not changing, but the x coordinates are the ones that change. So it is the points are moving parallel to the x-axis. So the x-axis therefore is the invariant line. So this is a shear with x-axis invariant. So a shear is a transformation in which points move parallel to the invariant line. So you can see these points are moving parallel to the x-axis. So that is what you're supposed to note. Now, how do you describe a shear? You describe a shear by giving the invariant line, and in this case the invariant line is the x-axis. The points are moving parallel to the x-axis, as you can see. And the next thing, you're supposed to give a shear factor. I'll show you how to obtain the shear factor. And also you need to state a point, object point and the image point that are not on the invariant line. That is how you describe. When you state the three, you have fully described that. So let us go directly to description. So let me describe that transformation here. So this is a shear with x-axis as the invariant line, and then that is the first thing you're supposed to give. Then the second thing you are required to give is the shear factor. Now, how do you get the shear factor? To get the shear factor, you need to identify the distance moved. That is the distance moved from the object to the image, distance from the object to image, and then divided by, this is how you get the shear factor. Then you do this, you divide by the distance of the point from the invariant line, distance of object point from the invariant line. So that is how you obtain, or that is how you get the shear factor. So to calculate the distance of the object to the image point, we shall take an example from A to A prime, from the object to the image. So we note that. So we'll go to the diagram that we have. So from A is -1, 1. Then A prime is 1, 1. So you can see those are two squares. So those are 2 centimeters or 2 squares. Therefore, that will give 2. Then we divide by the distance of the object point from the invariant line. Distance of the object point from the invariant line. So we take an object like A. Object point is A. So the invariant line is the x-axis. So you can see from the x-axis, which is the invariant line, to A, that is only 1 square. So that is only 1 square. So that would be 1. The distance is 1. So divided by 1. So therefore, the shear factor is 2. That would be applicable on the same when you take all the points B to B prime, C to C prime, D to D prime. That will be all the same. You should give 2, and you can confirm that. The next thing that we need to give in order to fully describe the shear, we need to give an object point and the image point, not on the invariant line. Object point, and image point, not on the invariant line. In this case, we can give, in this case, let's take B, for example, B. We can give B which is 1, 1, and then it moves to 3, 1. So that is what you can give there. We can give any other that is not on the invariant line. So in this case, we have A, which is 1, 1. Then it moves to A prime, which is 3, 1. So you can confirm whether that is the case. So yeah, A is -1, or B is 1, 1. Then it moves to 3, 1. So you can see that. So that is how you're supposed to fully describe the transformation T, which is a shear. And we gave this one as a shear simply because you can see that the points are moving parallel to the invariant line, which is the x-axis. So for example, look at C. It is moving parallel to the x-axis from C to C prime. Then look at D to D prime. Then A to A. So all of them are moving parallel to the x-axis, and therefore the x-axis is the invariant line. Note something else, that the points on the y-coordinate are not changing. Only the x-coordinate points are the ones that are changing. So that is how you describe that. So I want us to go to the next question, which is determine the matrix of transformation T. Determine the matrix of transformation T. Now, to determine that, we need to do some calculation here. And that is what you're going to do right away. So let me prepare some space here. Now, because we don't know this transformation, we can let that transformation be given by A, B, C, D. Let's let it be that. And then when we getting the image point, we pre-multiply with the matrix of transformation. So if we take these matrix of transformation, and then we multiply by A, B, and C, D, that should give A prime, B prime, C prime, and D prime. So that is how we should do it. Now, since we know all these points, they are given here. 1, 1, 3, 1. So 1, 1, 3, 1. So 1, 1, 3, 1. We are given these. So let me simply write them here. So 1, 1. Let me see. Oh yeah, let me confirm. Oh my God, this is -1, 1. The ABC. So that one, a quick correction there. So this one, the object points, and let's confirm these. So the object points are -1, 1, 1, 1, 1, 1, 4, and -1, 4. Then the image points are given there, as you can see. A prime 1, 1, 3, 1. Those are the image points: 1, 1, 3, 1, 9, 4, and 7, 4. So when we pre-multiply these with the ABCD, which is the matrix of transformation T, we should be able to get this value. So we don't need to use everything that is here. When we carry it up to that point, that should definitely give us the answer. So I will only multiply these matrices up to that point: A, B, then A prime, B prime. For multiplication of matrices, that one is done in the previous chapter. So this one, I assume that my students are aware of this and they're able to multiply matrices. If you're having a problem with the multiplication of matrices, maybe I'll prepare a tutorial on the same. So let me multiply this. A times -1 plus b times 1. That will give negative a. This will give negative a plus b. So a times -1, negative a, then b multiplied by 1. That is what is going to correspond to this 1. And then if I multiply now with the second row, that is b, I'll get a times 1, which is a, then plus b times 1, b. That should give me that value, which is 3. Now you can see that I'm forming a simultaneous equation, so solving this is quite easy. You can use elimination or substitution. And so for me to eliminate b, I can subtract. So this will give negative 2a, b will be eliminated, this is negative 2. So a will be 1. So substituting the value of a in any of these equations, you realize you get b as 2. So that is what you're going to use to get a and b. So to get b and c and d, I'll use these again. So c multiplied by -1, which will be negative c, and then plus d multiplied by 1, so this will give plus d, and that one will definitely correspond to 1. Then I go now to the second column, so this is a row multiplied by the second column, so c multiplied by 1, that is c, then plus d multiplied by 1, which is d. That one corresponds to that, which is 1. So I eliminate d again, so I'm going to subtract this. So negative 2c is equals to 0. So c is equals to 0. Substituting c in any of these equations, you realize you get d as 1. So those are the values of a, b, c, and d. So now the matrix T, which is given by a, b, c, d, will be a is 1, b is 2, c is 0, and d is 1. So that is the matrix of transformation. So that is simply how you obtain that. Now let's go to that part of the question. On the same grid as in A, draw rectangle A double prime, B double prime, C double prime, the image of rectangle ABCD and a stretch with the line y is equals to 1 invariant and stretch factor of 2. State the coordinates of this image. So the invariant line is 1, then this one is a stretch with a factor of 2. Now we need to understand a stretch. In a stretch, points move perpendicularly from the invariant line, and that is why for the first part of the question, the one that we've just done for shear, we didn't describe this transformation as a shear, as a stretch, because you can see the points are not moving perpendicularly from the invariant line. Invariant line being x-axis, the points are not moving perpendicularly. So in this case, we need to give we are given that A double prime, B double prime, C double prime is the image of rectangle ABCD. The invariant line is y is equals to 1. So we can indicate that line, y is equals to 1. So let me draw that, y is equals to 1. So y is equals to 1 is this line that moves from here. Let me draw that line. So I'll draw it there. So EF is you can see EF, that is the line y is equals to 1. Y is equals to 1. So that is the invariant line, and the object that we need to stretch is ABCD, as you can see. So points will move perpendicularly from that line. In this case, the points that are on the invariant line will not move. I need to explain that on well. The points that are on the invariant line, which is AB. Look at AB. AB, those points will not move. They are lying on the invariant line. So the points that will move are D and C. They will be stretched upwards. So in this case, we need to really understand these. We need to understand these. So these points, now to get a stretch factor of 2, now we want to know where D will move with stretch factor of 2. How do we get the stretch factor? Let me explain these. To get the stretch factor, you get, for instance, A prime D prime, you divide by AD is equals to 2. That should give us 2. So we need to look at the diagram here, and since we've said A will remain where it is for this stretch, since it is lying on the invariant line, and the invariant line, as you can see there, that is so the invariant line is the y is equals to 1, and those points will not move, A and B. So A double prime will remain where it is, B double prime, which is here, so A double prime will remain there, B double prime will remain there. So those points will not change. So D has to change. So for me to move this point twice, so you can see from A to D, those are 2 squares. There are 3 squares, and the stretch factor is 3. So you just need to multiply that by 2. So there are 3 squares from A to D. So since the stretch factor is 2, if you multiply that by 2, it has to move, you add other 3 squares, 1, 2, 3. So definitely that will be the point where D will be located. So you can rename this point. That point is D double prime. That is where we have. Then C would move again. When you look at B to C, that is 3 squares. So stretch factor is 3. So we have to add 3 more squares, 1, 2, 3. So it will move definitely there. So that's where we get C double prime. So that is where we get now the triangle that will, the rectangle that will be formed. Let me try to the segment. So there is a rectangle. I can try to hide this label. want to use a different color. So I want to show a different color so that you can see the difference. So as you can see now, we have a double prime will also be here, so we can add these. I can rename these A, and still the same point is a double prime. So this one again, that point is I want to rename this point. So you know why this one is not bringing the option of let me rename it when I'm here. So yes, there it is. Now you can see it well. So we have A double prime, B double prime, C double prime, D double prime. So that is the image of ABCD after a stretch. That is a Y is equals to 1 as the invariant line and the stretch factor of 2. So that is how you obtain that. So note that for a stretch, the points that lie on the invariant line do not change. In this case, Y is equals to 1. The points that are there is A and B. The points have not moved. The points that will move perpendicularly from that line of the invariant line is D and C. Then to obtain the scale factor of 2, you look at the distance from A to D, that is 3 squares. Since you are stretching that with a stretch factor of 2, you have to multiply that distance by 2. So there are 3 squares. When you multiply by 2, you have to count from A upwards, there will be 6. So now when you count A prime, D prime, you notice that this one will give you this will give you 6, then AD will give you 3, and that is what is giving you 2. That is how you get the stretch factor. I think now we are through with the questions. We've done the first part of the question. We drew the diagram, then we describe fully the transformation T. that is a shear, how we describe a shear. Then determining the matrix of transformation, we've done that. And then the last one, stretching that diagram, we've done that. So that is simply how you're supposed to work out that question. So thank you so much.